Hello, everyone. Welcome to our SketchUp for Landscape Design New User course. This is lesson number 2 in our series. I'm your host, Adam. It's my job to make it make sense. So in this video, we are going to be building on what we did in our previous videos. So if you didn't get a chance to watch part 1, please go back and at least run through it. The most important part of part 1 is the second half where we talk about the axis. Okay, so that's a very, very fundamental concept in SketchUp, and it's very important that you grasp it and understand it because we're going to continually reference it as we move forward. And it's going to become an integral part of both drafting and 3D modeling. So we will talk about the axis in future lessons and expand upon it a little bit. But we laid a little bit of the groundwork for how to think about it in the first lesson. So go back and watch that. So in this lesson, what we're going to do is we're going to talk about 3D geometry and break it down and define it. Because if you're new to 3D modeling in general, you need to have the language, right? So it's almost like learning a new language, both to communicate with other SketchUp users, but also to be able to Google things, to look up information, and then just to also help put the pieces together as you're starting to understand the logic. The language has to come first. You have to understand the definitions, and then you can understand the systems behind them, right? So, or how they apply to the systems that we're going to talk about. So let's just jump right into it. And if you guys did follow along lesson number 1, we set up our viewport in a specific way. We chose the construction documentation style, and we saved a default template, and we brought in 3 toolbars: the large tool set, the views toolbar, and the styles toolbar. So if you're just joining us for the first time, just make sure that you're set up so you can follow along. All right, so geometry defined, 3D geometry defined in SketchUp. The first thing that we're going to talk about is the endpoint, or also known as the vertex. The plural of vertex is vertices, okay? The vertices. So if you're, reading about 3D or you're watching tutorials and somebody references the vertex or the vertices, plural, then they're talking about the endpoint, is what SketchUp calls it. SketchUp doesn't directly call it a vertex. However, there are plugins for SketchUp that refer to its more common name than what SketchUp calls it, which is endpoint. Okay, so what SketchUp does is they try to take these 3D terms and make them simple. So it's kind of this layman understanding. I wish they didn't do that, because then you wouldn't have to learn 2 different things if you ever went outside of SketchUp. It can get a little bit confusing. It would be nice if there was a little more universal naming convention thing. So, endpoint vertex. What is it? Can it exist by itself? No, it cannot. It's not something, it can technically, but it's not something that will contribute to your model in any positive way by itself. It's not something that will show up. It's not something that you can render. It has to be a part of a structure. So an endpoint and a vertex is basically the point that holds an edge or a line, which is our second thing we're going to talk about. So edge, line, spline, those are all kind of terms for what you would know in maybe Dynarscape or AutoCAD as a line, right? Or an edge. So an edge is basically, this is a line or a spline when it stands by itself. It becomes an edge when it's a part of a face, let's say. So it's supporting a framework. It's a part of a circuit that is now has a closed face. However, in SketchUp, it just calls it edge all the time. So it gets a little bit confusing, though, because the tool to create edges is called the line tool. So understanding kind of the universal way that those terms can be interchanged is important. Okay, so getting back to endpoint vertex, the very end of this edge or line or spline is an endpoint. Okay, so if I would try to select it, I get nothing. Okay, so almost every other 3D application out there, you could do that and you would select the vertex. For some reason, SketchUp decided to make it so that you cannot select the endpoint and move it, which to me is a very, very big flaw. It's something that every other 3D application you can do, and it's very, very beneficial to be able to get in, grab the vertex, and move it. Now, you can move it with just the Move tool. Okay, you just can't pre-select it. So if I would come up here and grab the Move tool, and then I would hover over here, you can see it's going to say I'm on edge, right? And my wife would probably agree with that. However, if I go to the end, and I don't know if you can see that, but it's saying endpoint. So it's giving me this text tag, tells me what I have under the cursor or what I have under the Move tool. And you could kind of see that it turns green. I don't know if you can see that, but the green is the color that indicates an endpoint. So you have an endpoint there. Okay. So if I go over here, you can see I have an endpoint. And if we go to this square here, and again, I'm on the edge, but if I come here, now I'm on the endpoint. Okay. So you can get in and move. You could pre-select an edge and move it. However, and we're going to talk about the translate tools in the next video in more detail, but I need to show you a little bit of that just to kind of help understand what things are. All right, but I can't come in here and pre-select the endpoint. However, I can move it. So if I grab it here with the Move tool, now I can move just that endpoint anywhere that I want. So it's not that you can't move it, you just can't pre-select it. There is a plugin that allows you to work with endpoints called Vertex Tools. And Vertex Tools is a commercial plugin. You have to pay for it, but it kind of adds a missing functionality, in my opinion, to SketchUp. So if I would call Vertex Tools from my keyboard shortcut, so move this out of the way, you can see up here, Vertex Tools. And now I could actually get in here and pre-select an endpoint, and it'll tell me that I have one selected. It'll tell me how many vertices there are total. So there you see that naming convention start to come back in. It's not a native thing in SketchUp, but the plugin authors respect kind of the more universal terminology, and they tend to use it in their plugins. Okay, so it can be very confusing when you're trying to learn and then you're hearing these things and it's like, why is there so many different words for the same thing? So I'm trying to break it down so that you can kind of associate, okay, when I hear vertex, that's an endpoint. I understand that they are one and the same. Okay, so this gives us a lot more options that we can get in here and manipulate in a much more controlled manner with the Vertex Tools plugin. So we'll get into that later and talk about some of the most useful plugins for SketchUp. But for now, we're just going to kind of stick with the default things. I just wanted to let you know that that does exist. All right. So you could not have an edge, a line, or a spline without a vertex. Okay. You can have a vertex that's kind of floating out in space. It's not really doing anything. And I don't have the toolbar on, but there is a tool in Vertex Tools that lets you add a vertex anywhere you want. So you could drop one in. However, without that connection between those two endpoints, there's no native way in SketchUp to just add an endpoint by itself. So it's part of a framework. So let's think about how to tie this back into landscape or terms or something that maybe you guys would understand. one way to think about it, and I'm going to draw another edge up here. And I'm going to just use Vertex Tools just to kind of let us see the endpoints a little bit better, because it turns them into that blue marker. Or if I select it, they become red. And that way we can just visualize it a little bit better. So we have an endpoint there. If you don't have Vertex Tools and you want to visualize it, you can also go up into the Styles menu. We can go Edit, click on this first button for Edge Styles, and then come down here and click Endpoints. Okay, so now look what we got. So let's just bump this up. Let's just double it so we can really see what's going on. Actually, I'm going to go really, really big with this, like 30 or something. Okay, so now we can see where those markers are. That's the endpoint. So this will give us a really good way to think about it. And I'm going to make the analogy to a pipe fitting or a coupler or a connector or T-fitting, any of those things, okay? So these are kind of the things that connect straight runs in irrigation or drainage. In construction terms, I've built some geodesic domes, right? So I was thinking about the analogy of the hub in a geodesic dome, right? It's the point that you'd need this hub or this whole thing would fall down. This whole structure would tumble, right? The hub is the point that makes that structure possible because it's holding each piece together. So the only way that this 2x4 is suspended here is because of the hub. All right. So in a 3D framework, in a 3D model, the endpoints are like these little hubs here. They hold everything together. So similar with the coupler, they're the thing that these even look like couplers here when we turn on the endpoint style. You can see here, this is where you have an endpoint here that is breaking this line and creating a 90-degree edge out in the other direction. All right. So it's just something to think about. It's how things are going to be affected. If I get in here and try to move this edge, right, you can see how it's moving. It's bending and flexing at that joint. So if we would put another edge in here and then come grab here and try to move this, now it's bending and flexing at that point, but it's not bending and flexing at that very end edge anymore. Okay. So these are, this is the stick framing in a way, is another way that you can really think about this. All right. So the last thing is our face or polygon. So there's another set of interchangeable definitions. In every other 3D application, polygon is the universal term. In SketchUp, they call it edge. So in every other application, or SketchUp calls it face. Other applications for edge, they use spline a lot. So, or line. So it gets a little bit confusing, but just in SketchUp, you have endpoint, edge, and face. You guys probably aren't rushing out to use other 3D software anytime soon. But just know that sometimes in other extensions and, you're going to hear these other terms. So I just wanted to make you aware. But the ones to remember right now are endpoint, edge, and face. So when it comes to a face, what is that? So if you think of stick framing, right? And we would have walls that we were building, okay? So let's come in here and I'm going to actually delete these faces. Okay, so there is our stick framing. Okay, so maybe we even had a window in here. Okay, so all of the edges supported by the endpoints make up our framing, and then inside the framing, SketchUp will put this thing called a face or a polygon. So let me actually turn these off so you guys can see they're not in the way. All right. So there needs to be a specific set of things that are a checklist, right? So it needs to pass a test in order for SketchUp to create a face. So if we would, let me move this back a little bit and delete this edge. All right, so if I was looking at this, and let's go over here. We wanted to create a face right here, and we finished, we need to first complete a circuit. So that's the first thing, right? So if we think about it in terms of framing, we can't put drywall on unless we've framed out a complete circuit in order to screw the drywall in all the way around, right? So it's the similar thing. You need to have your framing in order to screw in your drywall, right? The drywall becomes now the face that you're going to either apply a paint to, you're going to apply a wallpaper to, you're going to apply a stucco, a brick, anything, right? So you do your framing first, and then you come and hang your sheetrock or your drywall or whatever you're putting up, right? Your hardy board. But first you need to have that frame. Now, in SketchUp, if you make a complete circuit and you close the frame all the way around, it will give you a face. So you get a face here. I don't know if you remember in the last video, we talked about the faces having two different sides, one white, one blue. And I think at the end, we actually changed the back to red so we could see it better. But you could see as soon as that face formed, it formed the back side forward. So what you can do is right click, go down to reverse faces. Same here, right click, go to reverse faces. All right, so over here, if we would redraw this edge, we're going to get another face that's closed because this meets the criteria for us to have a face there. And one of the things that's really, really, really important to understand is the concept of things being plumb, right? Just like you couldn't come and attach sheetrock to a wall that was way out of plumb, right? Or if you had a corner and we had a wall like this, and let's say one of these corners was pushed back just a little bit out of plumb or out of square, right? So this wall was not flush with everything else. It was pushed back a little bit. Well, if you went and tried to hang some sheetrock on there, right, you would probably break it once you got around. And you could screw it here, screw it here, screw it here. And then when you went and screwed it here, you would probably break it because it's not flexible. So the same thing in SketchUp. The faces are not flexible, that they can bend to meet something that's out of plumb or out of square or not flush with itself, right? So you need to have a complete circuit, no gaps anywhere, and things need to be all, and here's a term, coplanar. Okay? So a plane, just like, it's a flat surface, right? Just like a planar tool that we would take along wood to make it flat. In 3D, a plane is a 3D plane. So when you have your axis, your X, Y, and Z, you can think about the Z point here on the very base. This is our origin, and this would be the 0 plane. So if I would draw something here, like this is sitting, it's on the X and the Y, but on the Z, it's sitting on the 0 Z plane. Okay, but if I would lift it up 24 inches, now it's sitting on the 2-foot Z plane. So if you would think about this extending in all directions infinitely, that is a 3D plane. Okay, so if you would think about these corners that we talked about, all 4 of these need to be on the 2-foot plane for there to be a face here. If this one corner was on the, say 23 and 3/4 inch plane, and we move that down even a tiny bit, even a tenth, a 64th, and we move that down very, very small amount, that looks flat. Okay, but if we would draw an edge there and try to close this face, we're not getting anything, no matter what we do. All right, and you can't visibly really tell that that's out of what they call coplanar. It's not coplanar, right? Coplanar means all the edges, all the endpoints technically share the same plane. They coexist on the same plane. They're coplanar. Okay, does that make sense? So even though we move that down a 64th of an inch, you can't even visibly see it. Now we're not closing the face. All right, and this is what happens a lot of times to new users. They're just sitting and drawing, and you may not be paying enough attention, and you drew something that's just a little bit out of, it's non-coplanar. And then your face won't close. And it's very frustrating. And you don't quite understand what's going on, right? Well, that's 99% of the time, that's the problem. It's either an edge gap where you don't have things touching and there's a small little gap, or something's not coplanar, okay? So you're not going to be able to attach, let's say, your 3D drywall or your sheetrock or however you can think about it, because there is no flex in it. It has to exist 100% plumb, square, flush, however you want to say it. All right. Now, if we would instead be very careful, make sure we again mind our axis. Okay. You could always get in here to your edge styles. And again, it's up here, and then come down and change this to bi-axis, okay? And that way we can visualize it as we're drawing. As long as you make sure that that's green, and when you draw that, and we would come up and make sure that we hit that point exactly, okay? And then close that. Now you're gonna get the face, and actually I'm not. So there's still something wrong there. Something is out of square. Okay, so let me try that one more time. Let's delete it, and let's just make sure we are snapped in. And there's still something that is out of square. So I'm going to delete that side, and let's redraw here very carefully. All right, so that's going to happen to you from time to time. The best thing that you can do, there are ways to remedy this. There are plugins that will flatten. Vertex Tools, the plugin I just showed you, allows you to come in and scale everything on the blue direction to make sure everything's completely flat. So if I would just scale that up on the blue, that would generally flatten things out. And now we would get a face showing up. Okay, so there's free plugins that'll do the same thing, flatten and stuff, but we'll talk about that. Now it's important to understand why things happen the way they are. What are the rules? What are the logic? What things are we trying to understand and adhere to as we're creating our 3D model? Okay, so the concept of coplanar isn't just on the Z plane. When you are now if you think about 2D, when you talk about like AutoCAD and Dynascape and you're drawing in 2D, that's generally called like a Cartesian coordinate system. So it's the X and the Y. And in SketchUp terms, it's the green and the red. However, in SketchUp, it's a 3D software. So now we don't just have an X and a Y, we introduce the Z. And that means that there can be an infinite number of planes in every single direction, right? So coplanar can also be a diagonal plane out here that was coming up like this, Okay. And that would also need to be coplanar. All of these endpoints would need to exist on the same plane. That plane is just a diagonal plane. It doesn't matter necessarily that it's on the red, green, or the blue. Okay? They just need to exist on the same. It needs to be flat. Okay, that's it. It's not that complicated. They just need to be flat and exist on the same plane in order for you to get a face to show up. That's the only way that you'll get a face. And if you don't, you either have an edge gap or it's not coplanar. All right. Now there's a way that you can get around that if you wanted to cheat. And the cheat way is to draw. Oh, I am in wireframe mode. That's why my faces weren't showing up. Well, that's silly. So I did have a face there that whole time and probably had a face up here. So, all right. So the way that you cheat is to draw a diagonal edge. Okay. So it has to be like, imagine if this was framing, right? So if these were stick frame 2x4s and this one was pushed back. Well, you couldn't draw a diagonal line this way. I guess you could. Yeah. Because now those three are going to create a triangle, which is planar. All right. Or we could go the opposite direction. And now that's going to, it's going to be coplanar, just in a different orientation. Okay. So a lot of times we can come in, if we're going to cheat and put in a bunch of triangles, that'll end up closing our faces. It's not something that I recommend doing. I think that you should avoid it at all costs. I don't think that you should do that. I think you should force yourself to try to close it the right way, abide by the rules, because when you start doing that, it's going to cause you more problems down the road. You're going to end up chasing your tail. It's much better to make sure things are clean and modeled and drawn properly from the beginning. And I'm going to teach you guys how to do that as we go on. All right. So in our example over here, we have this wall. Obviously, if we would draw an edge there, we can see how far that's pushed back. So this is not going to close. If we would try to close this, we can close everything else like that. However, because that's out of plumb, this is not going to close. So we either delete that and redraw an edge from there to there like that, and that will close it. Or we would have to do something like this. Okay. And that would close it, because now we're creating three different coplanar surfaces. All right. But obviously, if you were drawing a house and you didn't, that wasn't the intention, and you're not modeling something that has that setback like that, you want this to be true and square. So you would delete that and redraw it. And that's the best way to make sure that everything closes and then you get your faces. Okay. So let's talk about polygons for a second, because again, SketchUp calls them faces. Other 3D software calls them polygons. So there's multiple different types, of polygons in general in the 3D world. And they are going to come into, they're going to apply as we go on. You're going to start to maybe see some of these terms pop up, just like we just did. One of them is triangle. Okay. Or in other 3D software, they call it a tri, T-R-I. So that's what we did when we connected that here to here. So now that was a polygon that is now a triangle or a tri. So another term for polygon is quad. Okay, so you have a triangle, three-sided polygon. Quad, four-sided polygon. So this is a quad right here. If I double click on it, I'm going to have 5 entities. If I deselect the face, I'm going to have 4 edges. I have 4 edges supporting that new face. That is a polygon defined as a quad. Okay? It gets complicated when we get into pseudo quads, but let's just stick to quads for now. The other kind of polygon is an n-gon. Okay, so let me make a quick list here so you guys understand. All right, so again, the types of polygons. We have the the triangle. You also will maybe hear the term triangulate, and that is when we do what I did, where we add a diagonal. We took that face and we triangulated it, okay? The second one is quad or quad face. You'll hear this a lot as we go. Quad is a four-sided polygon. Simple, but there's a lot of things we can do with quads. There's a lot of tools that rely on things that only work on quads. So when we get into some of the extensions, some of them require quads to work. So it's something that you kind of have to be conscious of depending on, especially if you get into something like subdivision modeling, it's 100% relies on quads or tris, and anything that's not a quad or a triangle will break what you're trying to do. So you have to model in a way that's conscious of these terms. All right, so the last one is n-gon, right? N means enter any number, like more than 4. So if it's a 5-sided polygon, 6-sided polygon, 7-sided polygon, 8-sided polygon, doesn't matter. It becomes an n-gon, right? Because quad is generally in most modeling software, anything where you're doing subdivision, you're doing what they call UV unwrapping, it relies specifically on quads. So anything outside of quads just gets a name n-gon because it's essentially not something that you want generally to work with for those things. So if you have an n-gon, that means that it's something that you have to work on or fix or make it quadrify it or triangulate it in a way to bring it back to a quad. So non-quad is another thing you might hear. So those are the types of polygons. They're not going to be relevant immediately, but down the road, if you get it further along into SketchUp and you start to use some extensions, these terms will come into play. They will definitely come into play if you ever go into something like Blender, 3ds Max, or anything outside Cinema 4D. True modeling softwares, you're going to run into these terms a lot more. All right, but in SketchUp, these are all considered just faces. There's no way that SketchUp defines them in the entity info. You just get a face, whether it's a tri, a quad, or an n-gon. It's just called face generally. Okay. So some of the other things that I wanted to talk about are in SketchUp, you generally do not have anything that is a true curve. Okay. So when it comes to an arc, we can get in here and draw an arc. Okay. Or let's just draw a circle. So let's go over here, grab the circle tool. Let's just draw a circle. Okay. And let's turn this into 3D with the push pull tool. Get into all this in a little bit, but here is a cylinder. Okay. I'm going to go up here to view and turn on hidden geometry. And now we can see that without hidden geometry, this looks just like a smooth curved wall. And if you're new to SketchUp, you might think, well, SketchUp makes curved walls. This is not true. SketchUp does not make curved, even when you use the arc tool. So if we get in here and we go to 2-point arc, okay, so that's a 1-click, 2-click, and then bring it out with the bulge. So that looks like a curve. However, it is not, again, a true curve in the sense that it is actually made up of endpoints and edges. Okay, it's not a true curve in the sense of there's only 2 endpoints, and then we have a mathematical curve in the beginning or in between those 2 endpoints. Excuse me. We have a bunch of endpoints supporting this curve. So if again, I'm going to bring up that Vertex Tools just to mark these out. And look, you can see that this is a framework that makes up this curve. All right. So this is a curve that, again, if we were thinking of it in construction terms or stick framing, this is individual boards that we've just defined a certain angle and that we've connected with some kind of hub or coupler, right? So if this was straight run piping and we wanted to make that curve, we would need to put a coupler on that was a certain degree that would get us around. That would give the illusion that it's curved from the outside. Or if we were going to take this and lift this up, and each one of these would have to be a flat piece because there's no curved drywall. There's no curved sheetrock, right? So this is framed out in a way. And then in between each one of these, we have an individual face that's making up what looks like a curve. Okay, but it's an important distinction to remember that in SketchUp, there are no true curves. Everything is made up of straight lines, straight edges, endpoints, and straight faces or straight polygons. Everything has to be coplanar. Okay, so even this curve has to apply to the same rules that each one of these faces has to be coplanar in order to make this up. So the same over here with the cylinder. And again, turn on that hidden geometry and then we can see it. All right, we don't see it necessarily because if we would click on this edge, why is it dotted like that and not a straight edge? Well, if we look up here in our entity info window, there's two little checkboxes that are checked. One is soft and one is smooth. So if we unchecked soft, it's now no longer this dotted line and it's a solid line. Okay. But the edge is there. However, it still looks pretty smooth in between. We turn off the rest of those. It still looks pretty smooth. But if we would come up here, grab that edge again, and then toggle smooth and turn that off, now you can see that it kind of changed the shading in between those two sides of that. So there's two small little straight coplanar faces on either side of this edge. And now it's a little sharper in between because we turned off soft or smooth, right? So I can turn off, I can make it soft and turn off smooth. And you can see, I don't know if you can pick that up there. Maybe I have to turn on, there we go. Now we can kind of see that we have the shading coming around with the shadow. And if I would play with this, you can see where it starts to catch that edge, right? Why is it catching that edge? Well, because that edge up here is not smoothed out. So we have smooth turned off on that edge. So if we would come back in here and turn it on, look at the difference, off, on. Okay, and you can exaggerate that with, I turned on use sun for shading in our shadows, but there, let me really exaggerate it like that. So now it's almost dark and light, but if I come up here and turn on smooth, you can see how it makes a gradient between those two faces. So it graduates the shading across there in more of a gradient. And there's a sharp and smooth, sharp and smooth. Okay, so that's something to keep in mind with these edges as well. But ultimately, what I'm trying to do is show you how these arcs are still made up of the same rules and the same logic and the same framing concept as everything else. So even if it's a cylinder, if it's an arc, if it's a curved wall, you're almost still kind of approaching it in the same way that you would at real life construction. Okay, so we could get in here and grab this one. And again, if we would grab the eraser tool, what we can do is we're going to hold control and we're going to erase this with control held down. And you'll see what happened is it turned on soft and smooth. So it's the exact same thing as if we grab that and turn these on manually. And you can start to see what happens. This is getting smoother as we go. Or we could grab the eraser tool and hold control and click and drag over all of these edges. And they all became smooth. So now if we turn off View Hidden Geometry, now that looks a lot nicer. And if we play with our shadows, you can see that it graduates across that face, which gives the illusion that it is a true curve or a nice smooth curve, even though we know in principle it's not. Okay, it's made up of flat individual pieces that are a part of a framework. All right, so these are important concepts. They will help you to understand SketchUp as we go. Things will make a lot more sense to you if you can kind of wrap your head around these basic concepts and these basic rules, that when you do get yourself in trouble, it'll be a lot easier to get yourself out of trouble by understanding and remembering what it is we're talking about right here. So again, this is also tying back to our axis lesson in the previous video, and why I was so dead set on telling you to make sure you stay on the red and the green and the blue. Okay, make sure that you're paying attention to that marker that says on green axis or the marker that says on red axis, because you don't want to get out of being coplanar. Okay, because if you do that, then your faces are going to form. And if everything you draw is drawn with that adhering to those rules, then you're not going to have any problems closing faces, and it's going to pass the check in order for SketchUp to make that face. And you're not going to have to come in here, try to figure it out, start triangulating things, having that headache. You don't want to do that. You want to make sure you pay attention, you draw things cleanly from the beginning, you understand the rules and the logic, and you stick to them. All right, so I'm going to leave it there for this video. I don't want this to go too long, so you guys can come back and reference this if you need to at a later date. All right, so I hope that, again, was helpful to you guys. And if you did have any questions about this, feel free to ask them in the comments. Please know we are going to continue on with this concept in the next video as we get into the move, scale, and rotate tools. So we're going to talk about translate tools in the next video. So I hope everybody has a great day, and I will see you then. Bye for now.